Hello students, today you are starting a new chapter from a mensuration part, that is surface area and volumes. For this chapter it is very important for you to know the basic formulas to calculate the total surface area, curved surface area and the volumes of different solids, which you have already learned in class 8 and 9. Here, the main difference between the class 8, 9 and here in class 10 for this chapter is, in class 8 and 9 you were calculating the total surface area, curved surface area or the volumes of the solids, of the single solids. Suppose this is a picture of cylinder. Suppose the radius and height is given of the cylinder, then you need to calculate the curved surface area or total surface area. Or for the cone, slant height is given, radius of the base is given, then you need to calculate the volume of the cone. So for the single objects you were asked to calculate the volumes, surface areas, etc. But for in class 10 you are going to calculate the surface area, volume for the combination of objects. Combination of the solids means, suppose a cone is surmounted on a hemisphere. Okay, that means this is a picture of a hemisphere. One cone is surmounted over here. Suppose it is a toy. Now you need to calculate the total surface area of this toy. Then what you have to do, actually you need to do you need to calculate the surface area of the hemisphere, then the curved surface area of the cone. Then you need to add these two curved surface areas. That will be the total surface area of the toy. Okay, there you don't need to calculate the base area of the cone or the circular surface of the hemisphere. Okay, now let's have a glance on the formulas. Now I will start solving some of the problems from exercise 13.1, that is based on calculating the surface area of the combination of solids. But before that, I would like to advise you that you should go through the examples given in the book. Then it will be easier for you to understand the problems. If you are having any kind of doubts, then you can ask us. Okay. To solve the problems of this chapter, at first you should read the question properly to understand the meaning of the question. Then you need to draw a image or figure for the respective question, and then you need to think which formula will be applicable to find out the required thing. Suppose the volume is required, then is there everything given for calculating the volume? Then apply the suitable formulas. Once you have drawn the figure properly, then you are almost done. It will be very easy to solve for you this kind of problems if you once draw the figure properly. Now I am starting from question number 5 of exercise 13.1. The question is, a hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Here I have drawn one cube whose edge is L unit, and from here, from one of its surfaces, a hemispherical depression is cut out. Suppose I am cutting this depression from here, from this surface. Okay, it is given that the diameter of the hemisphere is also L unit, right? Now I have to calculate the total surface area of the remaining solid if I cut out this one, this depression from this cubical block. So this hemispherical depression is actually of hollow is of the shape of hollow bowl, right? It will look like this, and the space inside this hemisphere will be hollow, and there is no such upper circular surface area because there is a hollow space, and we will have to consider only the curved surface area of the hemisphere, right? So it is given that the diameter of the hemisphere is L unit, which is also the edge of the cube, right? So the total surface area of the cube is 6L square, sorry, square unit, right? And since it is the diameter, if radius is r, then 2r equals to L unit and r equals to L by 2 units, right? R is the radius of the hemisphere. And what will be the total surface area of the hemisphere? That will be the curved surface area, that is 2 pi r square, and the upper circular surface is pi r square. But in this case, this upper circular surface will not be considered because there is a because it is a hollow space here. So the total surface area of the hemisphere here, the total surface area of the hemisphere will be only 2 pi r square, right? So the total surface area of the remaining solid is total surface area of the cube, this is square unit, this is 2 pi L by 2 square, because r is L by 2 unit. Now the total surface area of the remaining solid is total surface area of the cube plus the curved surface area of the hemisphere, that is actually the curved surface area, okay? And from here, see, since this is a hollow space, so we will have to subtract the upper circular surface area from the upper surface of the cube, that is pi r square. Okay, square unit. Now the total surface area of the cube is 6L square plus the curved surface area of the hemisphere is 2 pi L by 2 square minus pi r square means pi L by 2 square. Okay, now 2 pi L by 2 square minus pi L square is, this gives us pi L by 2 square, that is 6L square plus pi L square by 4. Okay, now if I calculate this one, it will give us, take L square as common, L square by 4. Okay, it will become 24 plus pi square unit. Okay, see in question number 4, a cubical block of side 7 centimeter is surmounted by a hemisphere. That means cubical block is surmounted. That means, suppose question number 5, I was taking out the hemisphere from the cubical block, but here I am plotting the hemisphere on the cube, right? So the upper surface will look like this. This will be the base of the hemisphere, circular base, and this is the surface of the cube. It is given that the edge of the cube is 7 centimeter, right? Now they are asking that what will be the greatest diameter for the hemisphere. So it will be 7, right? If I am drawing a small hemisphere, or I'm putting a small hemisphere, then the block will look like this. For that case, the maximum diameter, the diameter cannot be equals to 7, right? But if I take the hemisphere of this shape, the diameter of the hemisphere will be equals to the edge of the cube. Okay, so the greatest diameter for the hemisphere, that is 7 centimeter, the greatest possible diameter. Here how to here they have asked, and they have also asked, find the surface area of the solid. So for finding out the total surface area of the solid, I have to calculate the total surface area of the cube. With that, I have to add the curved surface area of the hemisphere and from that we have to subtract the circular base where r is the radius, the hemisphere. Okay, this is the required surface area. Here r will be equals to 7 by 2 centimeter. Now according to the formula it will be 6 into 7 square plus 2 into pi into 7 by 2 square minus pi into 7 by 2 square, 6 into 49 minus plus it will be pi into 49 by 4. After that you just have to calculate this one. Okay, do this calculation by yourself.